Give me one moment. Okay. Let's get started. So we actually have a lot of work problems to go over today and probably next week too. So if you notice homework 6, have any of you looked at homework 6? It's like word problem. Every question is a word problem. So but it's like 3 types. So there's like exponential decay, population growth, Newton's law of cooling, and then related rates. So I'll be doing related rates next time. Yeah. So we'll kill like 2 of them today. Okay, so exponential growth and like Newton's law of cooling, they all satisfy like a certain differential equation. So I think it's dy dt equals ky. So here, right, let me just say, this is called a differential equation. So what is that? So normally in math 2a, right, I give you a function and then you take the derivative, right? So differential equation is like the opposite. So I tell you that a function satisfies this equation. Oh, yeah. So basically here, you're basically trying to find y. So it's saying what function we take derivative of it, it's a multiple of itself. So an easier one would be this. You all know this one. If it's just itself. So what function do you know? What's the solution to this? So what functions do you know where when you take derivative of it, you get the same thing back? What is y? Yeah, y can be like, in this case it's ddt, because we think of t as time, so it's e to the t, right? But you can have a lot, right? Like y equals 2e to the t, right? Derivative of 2e to the t is still 2e to the t, right? And similarly, like, yeah. So here, right, there are many options. And then if you think really hard, like, not too hard, but a little harder, you can sort of figure out what ky. How do you get a multiple of itself? Well, it has to be some variant of this, right? Because that's the nice thing about exponential. And if you think a little hard, like, you're gonna see it's this, right? It's chain rule. So when you take derivative of it, you get itself, and then chain rule gives you the multiple, right? And similarly, 2e to the kt. All of these are solutions to this differential equation. Dot, dot, dot. But it doesn't have to be 2, by the way. It could be like any number, so like pi. But let me just warn you. I think math 3, is it 3D? I forgot. But you go more into differential equations, so it won't be as basic as this. It'll be like more and more harder differential equations, and then you'll be asking what function satisfies this. So you should think backwards in this sense. Okay, but you see how it's not unique, right? So to make it unique, they normally put an initial condition. So y of 0 is a. So if I say y of 0 is a and this, then there's a unique solution. It's y equals a e to the kt. Because I must be, a at 0. So when I plug in t equals 0, e to the k times 0 is just 1. And then I get y equals a, right? So you see that I guess to be, y of t to be more precise. But yeah. So with an initial condition and this differential equation, you have you know the solution. It's given by this equation. So let me just say stuff like population growth, bacteria, I don't know how to call it, like chemistry stuff. Let me just say chemistry stuff, like all the EMs, like strontium, like the periodic table stuff, periodic table stuff. Like they like, for this is exponential decay, and this is like exponential growth, right? If you think of like bacteria, they multiply exponentially. Here, like stuff decays exponentially. Yeah. Don't ask me on chemistry. Okay. So is everyone clear on this? So like these type of things satisfy this differential equation is the whole point. So let's do a few questions to see how it goes, right? So let me just say, right, in the case of population growth, what is this? This is like initial population, right? Y of 0 at time 0 is like the initial population, right? Here is like the initial amount, right? Amount of bacteria. And same here, it's like initial amount, right? So let's do some examples. Let's do some bacteria ones and then chemistry ones, yeah? A bacteria culture grows with constant relative growth rate. So this just means, it satisfies that equation. The bacteria count was 400 after 2 hours and 25600 after 4 hours. 6 hours. A, what was initial size of culture? B. So this is asking for what's the initial population. Find the number of bacteria after 4.5 hours. C. Find rate of growth after 4.5 hours. Okay, so I have my I'll write, I don't know, P for population, even though what do you say, like, I don't think you normally say population of bacteria, right? That's for like people. Maybe A, A for amount. A of T is A naught E to the KT, right? So it satisfies this type of equation. So I'm given two information, right? So basically the part A is asking what is A naught. Yeah, because that's the amount at time 0, right? When you plug in T equals 0, you get A naught. So it's asking what is A naught. So let's use the information we have, right? It's 400 after 2 hours. So I know A of 2 is 400. So I have 400 equals A naught E to the K 2K. And then I have 25600 equals A naught E to the 6K, right? So you have two equations, two variables, right? You could solve for K, solve for A naught. All of these questions, it's the information they give you is to solve for K and like whatever your initial population is. It's always like that. Even though like the word problems might be different, that's pretty much it. So let's divide. Yeah, let's divide, this by 400. So since they're equal, that's the same thing as dividing A naught E to the 6K by A naught E to the 2K. So I want to solve for K first. Yeah, so A naughts cancel. So what do I get? What's 256 divided by 4? 64. And then you get E to the 4K, right? So natural log. So K is, if you just natural log both sides, natural log of 64 over 4, right? So from here, what do I have? Well, you can solve for A naught, right? Just plug it into one of these equations. So 400 is equal to what? A naught E to the 2 times ln of 64 over 4. And so 400 is A naught E to the 1/2 ln of 64. So again, what's the property of ln? I can raise it to the power, right? So this is the same as 400 equals A naught E to the ln of square root of 64, and that's 8. And this cancels, right? So 400 equals A naught times 8. And so A naught's 50. Yeah. So your answer to this is 50 for part A. And number of bacteria after 4.5 hours. So let me just say, how do I say this? It's going to be, if I erase can I erase some stuff? Because I want to keep the same page. So I have, so for part B, I know my equation now. It's 50 e to the ln of 64 over 4t. So for part B, right, you just plug in t equals 4.5, right? So basically this is asking for a of 4.5. So a of 4.5 is equal to 50 e to the ln of 64 over 4 times 4.5. Yeah, whatever that is. Yeah, I'll let you all calculate that. And then part C, well, what's part C? Well, what's the rate of growth, everyone? So Renese's rate, what should you be thinking of? No. If I have a function, I mean like you have a function that's like sort of like, okay, how about this? When do you remember like the velocity problems? When I give you like the distance function, what is velocity? Right? Think of velocity as like rate, right? So yeah. So is this asking what's the derivative at 4.5? So well, let's take derivative. Well, a prime of t is what is this? 50 times ln 64 over 4 e to the ln 64 over 4 t, and then your answer is just this, right? So it's the derivative at the point, you know, ln, and then whatever this is, yeah. Or you could just type this whole thing on WebAssign. So this is the answer for C. Everyone clear so far? It's always the same thing. Like the information they give you, it's define K and initial most of the time, and then once you know that, the questions become easy. So let's do some chemistry ones. Examples. So strontium has half-life. Oh, so by the way, before I do that, chemistry. Chemistry definition. I'll write it like that. So half-life means amount of time it takes to get half the initial amount. Yeah. So makes sense, right? That's why you call it half-life. So example, strontium. I don't know what strontium is, but whatever it is, strontium 90 has half-life 28 days. Yeah, I figured it's some element in the periodic table, but I don't know. I got like a 3 in chemistry AP, so I'm not the one to ask. Okay, so a sample has initial mass 50 milligrams initially. Find formula. So it's basically find A of t with like K and initial amount solved. Formula for mass remaining after. So I guess I'll be erasing because I want to keep like the same page. Yeah. So just so like we're all clear. And then find mass remaining after 40 days. And see how long does it take sample to decay to a mass of 2 milligrams. Okay, so again, the first thing you do, write out the number, yeah? So A of t, I guess in this case, it is also amount. So A of t is A naught e to the kt. Now, question, even if they didn't tell you the initial mass was 50, you can actually find K just from the top, right? Because what does half-life mean? It's the time where you have, so it takes 28 days to get half the initial amount, right? So when T is 28, what's A of 28? It's 1/2 A naught, right? Everyone agree? Because A naught's the initial amount. So half-life is the amount of time it takes to get half the initial amount. So if the half-life is 28, after 28 days, I have half of A naught, right? Or you could write 1/2 of 50 equals 50. But in any case, we're just going to divide by A naught, right? So you get 1/2 equals e to the 28k. And you're going to get, if you solve, you're going to get k is ln of a half divided by 28. Right? So the answer to A is A of t. And then here they give you A naught. So A of t is 50. E to the ln of 1/2 divided by 28t. Yeah. So that's the answer to part A. And you see, once you have like A naught and K, the all the other questions is easy, because like you see, for part B, what is to find mass after 40 days, you just plug in T equals 40, right? So this is just asking for A of 40. So it's 50 e to the ln of a half over 28 times 40. That's your answer. And then part C, it's the vice versa. How long does it take to decay to 2? So they're telling you A of t is 2. Find T. So 2 equals 50 e to the ln of a half over 28t. 1 over 25 equals e. So t, if you solve, if you ln both sides, you're gonna get ln of 1 over 25 times 28 over ln of a half, I think. Yeah. And it's in days. So is everyone clear on this? Once you see it done like 1 or 2 times, it should become automatic. So okay, well, half-life, right? What does half-life mean? It's the amount, it's the time it takes, sorry. Maybe amount of time. Okay, yeah, amount of time works. Yeah, it's the amount of time it takes to get half the initial amount, right? And they tell you the half-life is 28. So A of 28 is what? It's A naught e to the k times 28, right? But by definition of half-life, it's good. This is 1/2 A naught, right? It's half the initial amount. And then, I mean, divide by A naught if you like on both sides. Get a half equals e to the 28k. And then I just solve for k. And just ln both sides and solve for k. Do you follow? Or okay, cool. Okay, let's do one more and then we'll move on to like Newton's law of cooling. So it's pretty much the exact same thing, but let's do one more chemistry. I find this funny. So a sample of, I'm pretty sure it's made up, I don't know, Einsteinium. I never heard of an element with the name of Einstein, but 252 decayed to 64.3%. I don't know, it might not be made up, of its original mass after 300 days. A, what is half-life? of Einsteinium. Oh, really? Oh, okay. Is the number like is that telling you like the number on the periodic table? That's my guess, but uh, like the 252. But okay, how long would it take the sample to decay? Oh, okay. To 1/3 of its original mass. So again, but before you look at A and B, just write out your equation and see how much information like this thing tells you, right? This thing right here. So let's use A again. Maybe you could use M of T because it's mass, but so what do I know? I know after when T is 300, so A of 300, right? What do I have? I have 64.3% of original, right? So it's 0.643 times A naught, right? And with this, you can solve for K. It's like the word problem is like worded differently, but really it's the same exact process. So you have 0.643 equals e to the 300K. If I'm just gonna write what it is, ln of 0.643 over 300. Yeah. So what's the half-life? Well, now that I know this, right, it's e to the ln of 0.643 over 300 t, right? So for part A, well, what's the half-life? Well, it's exactly what we did before, right? What does half-life mean? It means when I have half the initial amount, right? So I'm trying to find what t is for when I have half the initial amount. And hopefully you all see it's pretty simple, right? If you just solve for t, ln both sides, you get ln of a half, or let me just write like this, 300 ln of a half over ln of 0.643. So let me just write the answer here. Over, is it days? Yeah, days. And part B is pretty much the exact same thing, right? Instead of 1/2 the initial amount, it's 1/3 the initial amount. So you're basically finding for t again. So the answer is like A and B become immediate once you have the equation. Like once you have K and A naught. In this case, once you have K. But here you get sorry, there should be an E here. Yeah, let me it's hard to write small. So you if you do the work, it's gonna be yeah. Does everyone follow with this? Makes sense? Or get the process? So that should cover like the chemistry part of your homework, at least. So or like chemistry and like population. So whenever I didn't do one with population, but whenever you see population, bacteria growth, some chemistry stuff, it's all using this equation. Okay, so let's move on to Newton's law of cooling. Newton's law of cooling. So basically, T of T is temperature of like whatever object at time t. And Ts is temperature of surrounding. Yeah, so if you think about it, right, like if you microwave something, yeah, and then you bring it out the microwave, if the outside is cold, right, it's cold, it's gonna cool your thing, right? If your object is hotter than like the surrounding, eventually it's gonna go down, right? The temperature of whatever you just heated. So same idea. So this is sort of like an equation, a differential equation to capture that. Yeah. How like temperature of an object gets affected if you include the surroundings. And it's given by dt, right? So I mean, this is shorthand for t of t, right? Kind of like how instead of nobody writes this, right? like we sort of exclude the variable, right? So we write df dx. So same exact thing here, right? So I mean, if you want to be pedantic, this is a function of t, but most of us don't write that. So dt dt is kt minus ts. Yeah. So let me just say in English, it says rate of cooling proportional to difference of temperature of object and surrounding. I mean, of course, like, cooling, because most of the time we think of, outside is colder than the object, and then it cools the object down. But it could be, it could be heating. Yeah. So I mean, but this is just a name, like if it was me, I would call it Newton's law of cooling / heating, right? But yeah, anyway, so now that we have this, let's do some examples. So example, ran a hold on. Okay, so when a cold drink is taken from a refrigerator. So after this one, I'm gonna do like one of them on your homework, just to show you how it's done, right? But I mean, but once you see this, you should be able to do the one on your homework. But we'll go over it as a discussion class together. Temperature is 5 degrees Celsius. After 25 minutes, in a 20 degrees Celsius room, its temperature has increased. See, so in this case, it's increased, right? Because the surroundings hotter. Because I mean, you just brought it out of the fridge, right? So in this case, I would call it Newton's law of heating. But okay, A, what is the temperature of drink after 50 minutes? This one I might use 2 slides, but what Ren will temperature reach 10 degrees Celsius. So so our equation, right, is this, right? So if I let T of T, so let T of T, in this case, what's the object? It's the drink, right? Let T of T be temperature of drink, T minutes after taken from fridge, yeah? From fridge. right? And then they tell you TS is 20 degrees Celsius, right? So what does Newton law of cooling say? Newton law of cooling says this, right? Everyone follow so far? Okay, so from here, it's just a substitution. Because if you remember from the very beginning of this discussion, if I gave you this differential equation, right? Ky, and then y of 0 equals a, you know the solution is this, right? Everyone agree with that? So right now we don't have this, right? But we could say let y of t be t of t minus 20. Yeah? Then question, what is dy dt, everyone? It's the derivative of this, which is dt dt, right? I told you to shorthand. And then, so it's equal, right? Because derivative of 20 is 0. So you see here, right? If I let y be this, I get dy dt is equal to, right? dt dt. But what is dt dt? It's this thing, right? It's k, and then t minus 20 is y. So now I am of this form. Yeah, I have something of the form. If you just put this one and this one together, dy dt is ky. Agree? So all I need to know is what's y of 0, right? Once I know y of 0, I have my formula. Everyone follow so far? Yes or no? Okay, well, let's figure out what y of 0 is. Well, I know y of 0 is from this equation right here. So let me put this in red, right? Y of 0 is t of 0 minus 20, right? Well, what's t of 0? Well, t of t is temperature of drink t minutes after taken from fridge, right? So at 0 minutes, what was it? It was 5 degrees Celsius, right? If you read it, like right when you took it out, when no time has passed, it's 5 degrees Celsius. So this is 5 minus 20, it's negative 15. So my equation is, do I want to, where do I want to write it? Let me just try to write small. Y equals negative 15 e to the kt, right? Everyone good so far? Okay, well, let's find k. We still haven't used information, right? We still need to use this. So after 25 minutes, the temperature has went to 10 degrees Celsius. So I know at t of 25 is 10, right? So what's y of 25? It's t of 25 minus 20, right? I'm using the red underline equation. And so it's 10 minus 20, which is negative 10. Okay, so now I can find k, right? Using this thing right here. So y of, if you like, this is y of t. Again, I'm writing it for shorthand. Y of 25 is negative 15 e to the k times 25. And y of 25 was negative 10. So what's k? If you solve for it, I think, let me see. What's 10 divided by 15? 2/3? Is that 2/3? Yeah, it's 2/3. So k is ln of 2/3 over 25. Okay, I think I need to use another sheet, but our equation right now is y of t is, well, sorry, what was it? Negative 15. Yeah, negative 15. And then e to the, and then we found our k was this. Yeah. And now you're pretty much done. So let's solve the problem, right? We have our equation. So part A, Ren is temperature of the drink. What is the temperature of the drink after 50 minutes? So if you know, what is this asking for? This is asking for T of 50, right? I mean, if you look at what T of T is, you're going to see that this is T of 50. So let's find Y of 50, right? Once you find Y of 50, use the red underline red box equation, and then you get T of 50, right? So what's Y of 50? It's negative 15 e to the ln 2/3 over 25 times 50. Is this nice? Oh, 50 goes into 25 two times, right? So e to the 2 ln of 2/3. So again, I could simplify this by squaring it, right? Because this is the same as 2/3 squared, right? The property of logarithms. So this is negative 15, and then the e and ln cancel. So I get 4/9, and this should be negative 20 over 3. And then you're done, because again, from the red underline, y of t is t of t minus 20. So y of 25, or y of 50, sorry. So I know y of 50 is negative 20 over 3 equals t of 50 minus 20. So your answer is, what is that? I'll just write 13.3 repeat. Yeah, it's like 13 and 1/3. So that's for part A. So you see, it's a little harder than the population because you don't exactly get your differential equation. You have to make a substitution, right? So like this thing is like close to being your differential equation, but there's like a minus 20. That's annoying. So we let y be t minus 20, and then we get it of that form. Okay, so again, Ren will temperature reach 10 degrees Celsius. So it's asking Ren is T of T equal to 10. Yeah. So what do you know? So interpret it in terms of Y, right? So if it's asking Ren is T of T equal to 10, well, Y of T is equal to T of T minus 20, right? If it's asking Ren is T of T equal to 10, well, that's asking Ren is Y of T equal to negative 10, right? And from here, you solve again. So this is for part A. This is your answer. And then for part B, it's asking, you just equate it, and then you solve 25t. And then whatever this is, right? So I'll just write the answer. T is 25 times ln of a third. If you solve, you're gonna get this. Yeah. Okay, so I'm going fast because I want to go over your homework question. So what is it? A freshly brewed cup of coffee has temperature 95 degrees. So it might be different numbers, but in a 20 degrees Celsius room, run its temperature. Yeah, when its temperature is 70 degrees Celsius, it has cooling at a rate of 1 degree Celsius per minute. When does this occur? Okay, so again, let's, I mean, the numbers might be different from like what you see on WebAssign. I think every student might have like different numbers. Yeah. I mean, I don't think the numbers matter, right? I feel as long as you understand the idea, that's better. actually, I think this is better. So once I do it here, you can try to redo the problem with your numbers, as practice. Okay, so again, like T of T is temperature. I'm just gonna write temp, yeah, for temperature. Temperature of coffee after T min. Is it after? Mm-hmm. Yeah, it doesn't really tell me it doesn't tell me like seconds or days, but after time T, yeah, has passed. So again, our equation is this, right? And then my TS is 20 in this case, right? It's a 20 °C room. That's my surrounding. Again, same exact process. What did we do last time? We want a differential equation, right? So we let y of t, lowercase t, be equal to t of t minus 20, right? And again, you could check that dy dt is just dt dt, right? And dt dt is this, which is ky. So again, we have our differential equation. And, and what is y of 0? Well, y of 0 is t of 0 minus 20. What's t of 0? Well, at the beginning, it's 95, right? So it's 95 minus 20, it's 75. So I have my differential equation, ky, and I have y of 0 is 75. My solution is y of t equals 75 e to the kt, right? Everyone follow? It seems like I wrote a lot, but really I just wrote what y was. So okay. Now let's try to figure out what to do next, right? So it tells me when its temperature is 70 °C. So when T of T is 70, right? It tells me dt dt is what? The rate is the derivative, right? So this is the derivative, is 1 °C per minute. So is it +1 or -1 if I'm cooling? What should my rate be? This is like the only tricky part. Before, when we're heating, the rate is -1, right? Because we're cooling. Okay, but as I wrote here, right, dy dt is again dt dt, right? So I have -1 is, what do I call it? So I also have that dy dt is, how do I say this? So from here, let me just write using this thing right here, right? Dt dt is -1, so dy dt is -1, right? So dy, if I erase this, dy dt is -1. And when t of t is 70, right, which is here, what is y of t? Well, y of t is t of t, which is 70 minus 20, so it's 50. So y is 50. So I have -1 equals 50y from the red underline equation right here, right? So, oh, sorry, 50k, 50k. 50k. So k is -1/50. So I get y of t is 75 e to the -1/50t. Everyone follow so far? So again, when t of t is 70, d capital T dt is -1, but these two are equal. So dy dt is also -1. And from this equation right here, if t of t is 70, y of t is 70 minus 20, which is 50. So I have like, this thing's -1, this thing's 50. and then I solve for k. Yeah. And so now what do I do next? Well, it's asking when does this occur, right? So so let's just solve, right? So y of t is 50, right? So y of t is ren is y of t 50. So 75, because when y of t is 50, my temperature is 70, right? So this is whatever the answer to this is. So let me just say, if you solve for this, you should get like, because 50 divided by 75 is 2/3. So you should get negative 50 ln of 2/3 as your answer. Yeah. I know I went fast, but I was running out of time. Does everyone follow with this? Yes? No? Oh yeah, so try it yourself for, your homework. I'm pretty sure the numbers are changed, but it's pretty much so. Again, all this information is just that is for you to find k, and when you find k, you can find y, and when you know y, you know t by this relation, right? So that should solve like all your homework questions except like related rates and like differentials, which I'll go over next time. Okay, cool. Yeah, that's all I have for today. So just wondering, do we have discussion on next week Thursday? Or like, is it Thanksgiving and we have it off? Or okay, well, yeah, I'll see you Tuesday and then next Tuesday.